Hello everyone, welcome to the Makri Virtual. Hope you are doing good. Today I'm going to continue with the same module, that is a procedure programming module, and the same chapter, that is the C under the Linux. That is how to use C under the Linux. That is chapter number 20. In the last class we have studied about the processes, that what is a process and how we are using the processes, and what are the types of processes, and the more approach about the processes, that is what are the types of approaches that is available in the processes. One of the main process that is available is the fork process, that converts or that makes the comparison between the child process and the parent process. So this is, suppose we want to execute a program on the disk as a part of the child process. For this, first we should create a child process using the fork function. So this function is used, that is known as the fork function, and then from within the child process we should call an exe, that is the executable function, to execute the program. So one of the function that is used is the fork function, and the next function that is used is the executable function, that is the exe function, to execute the program. It is a library function that is available that has the same job as the execl function, that permit us to pass a list of command line argument. So we have studied multiple processes and multiple ps command and the get id, that is how to generate the get id. One more id is available, get is the get ppid, that is a get parent PID, that is a process ID that is available. You can tally the PID from the output and convince yourself that you can understand the fork function as well. And one of the more function that is available, that is the init function, that is used for the initialization of the process, right? And this is a program that we have discussed, that is how to use the, or how to call the parent process and how to call the child process. As well as we have also done the practical approach on the functions, that is how to use the functions in a predefined manner. So let us now see a program that uses executable CL function to run a new program in the child process. This is hash include unistd.h, that is a unistd.h is the header file. Then there is a int main for int main function. Then there are variable declaration, that is first of all the variable is declared of the int type, that is of process ID, that is a PID, and then uses the function, that is a fork function, and the output is transferred into the PID. This is the function that we have studied. Then uses the comparison, if it equals to 0, then the output of the fork function is 0. Then uses the executable command line arguments, and this is the these are the parameters that is passed over here. This is the explanation of this execl function, that is the absolute part that we have discussed in the last class. Now let's move to the next topic, that is a today's topic, that is what we are going to cover in the today's class, that is the zombies and the orphans. That is what is zombies and what are the orphans that is available. We have started about this, that is what is zombies, but a little bit about the zombies and the orphans. So today I'm going to continue with the same topic, that is the zombies and the orphans. This says, we know that PSA command lists all the running processes. That is, this is the command that is available, that is used to list each and every process that is available in the that is available with the operating system, not in the, that is available with the operating system, but from where PS program get this information. That is, PS list each and every information, each of the running process, but from where it is getting these information. So PSA command is used or get the information by using the concept of a table that is known as the process table, and that process table is available that contains the entry of the exit code of the process. This integer value indicates the reason why the process was terminated. That is, the integer value is given, that is a process ID that is used to communicate with the zombies and the orphans. Even though the process comes to an end, its entry would remain in the process table until such time that the parent of the terminated process queries the exit code. This act of querying deletes the entry of the terminated process from the process table and returns the exit code to the parent and then raise the query. So this is the process how this could be done. And when we fork a new child process and the parent child and the child That is whenever we fork a new child process, so the parent and the child continue to execute. There are two possibilities. Either first of all child ends, either first of all parent process ends. So it is the case either the process parent end first or the child process end first. Let us now discuss these possibilities. That is who terminate first and who terminate next. The first possibility is child terminate earlier than the parent. That is the child terminate earlier than the parent. It is the case that is available. In this case, till the time parent does not query the exit code of the terminated child, the entry of the child process would continue to exit. That is, this is the case that is available, that first of all child terminate as compared to the parent. What is the scenario? In this case, till the time parent does not query the exit code of the terminated child, the entry of the child process would continue to exit. That is, until the time it is available, the code is available to the child process. Such a process in Linux terminology is known as zombie process. So whenever the child process will terminate or would continue to exist, such a process is known as the zombie process. It says zombie means ghost, or in simple terms a bhoot in Hindi terms, in Indian terms. Moral is a parent process should query the process table immediately after the child process is terminated. So parent process immediately uses the exit code of the parent process, exit code of the parent process ID, so that it is available or it is used for the it is used in the communication for the parent. This would prevent a zombie, right? But what if the parent terminate without the querying? So this is the case. It is the parent is querying to the child, so the child would know how it will available or how it will be used. But what if the parent terminates without any querying? That is, without any information, it is terminated. In such a case, the zombie child process is treated as an orphan process. That is, the zombie process is available or treated as a orphan process. Immediately, the father of all processes in it adopts the orphan process. That is, then on the immediately init process is used, that is the initialization process is used that adopts the orphan process. Next, as a responsible parent, init queries the process table, as a result of which the parent process ID is terminated or eliminated from the process table. So init is the process, that is the initialization, which controls or which acts as a result of which the child process entry is eliminated from the process table. Now let's move to the second case. Let's move to the second possibility that is available, that parent terminates earlier than the child. So this is child terminate earlier than the parent. This is the time the parent terminates earlier than the child. Since every parent is launched from the Linux shell, that is, every parent is launched, used or launched from the Linux shell, the parent of the parent is the shell process. That is like a supervisor. The supervisor of the parent process is the child or shell process. Right? When our parent process terminates, that is, when our parent process that is available that terminates, the shell queries the process table. Therefore, thus a proper cleanup happens for the parent process. That is, a proper cleanup happens is available for the parent process. However, the child process which is still running is left orphaned. That is, the child process that is still available with the operating system is left orphaned or is become orphaned. Then immediately the init process would adopt it, and when its execution is over, init would query the process table to clean up the entry for the child process. Note that in this case, the child process does not become a zombie. That is, the child process does not become a zombie in this case whenever the parent terminates earlier than the child. Therefore, when a zombie or an orphan gets created, the operating system takes care and ensures that a proper cleanup of the relevant process table is used. That is, it is a responsibility of the operating system to use or to clean up the relevant process table that is available. Uh, Therefore, when a zombie process creates the OS, it takes care of the cleanup of the relevant process table that is available. That entry happens. However, as a good programming practice, our program should get the exit ID of the terminated process. That is, our program is available or gets the exit ID of the terminated process and thereby ensure a proper cleanup. So it is a responsibility of OS that it should exit or it should use the exit code of the terminated process and thereby ensure a proper cleanup over here. Note that here cleanup is important. Why? Because cleanup is important in this case. Why it is important to get the exit code of the terminated process? It is because means why the exit code is very important in the child process or the parent process. The reason is that it is the exit code that would give indication about whether the job assigned to the process was completed successfully or not. So it is because or it is the reason why it should give an indication about whether the job assigned to the process was completely or completed successfully or not. The following program shows how this can be done. That is how this can be done. It shows the this is the program. So there are two header files first of all, that is the hash include unistd.h and the systypes.h. So these are the two header files that is included. One is the unistd.h and then systypes.h. Then there is a int main, that is starting of the main function, that is a int main. Then it is a variable that is defined, that is I is initialized to the 0 and it is of unsigned integer, that is the unsigned int. These are the again two variables that is used, that is PID and the status. So these are the two variables that is used, that is of integer type. Then uses the fork function and gets the output of the fork function into PID. That is PID stores the output of the fork function. Then checks the condition. If it is equals to 0, that is if it is equals to 0, then simply use the while loop. That is while I is less than 429, 496, 729, 5u. If it is the case, then I++, then simply printf the child is now terminated. So this will print as it is, that is the child is now terminated. Then closes the curly braces. Else, if it is not the case, it is not equals to 0, otherwise uses the wait PID and percent status ends in 0. So these are the cases that is available over here. Then checks the condition. If WIF exited status, that is the WIF exited status, that is the WIF exit, that is the exit code is available, then simply printf parent child terminated normally. It is print as it is, that is the child terminated normally. Otherwise, if the status not exit, that is the exit is not the status, then printf that the child terminated abnormally. This is the syntax how it will be used. So first of all the variables are declared, then stores the output of the fork function into PID, then check the condition. If it is the case, if it is equals to 0, then simply again check the condition using while loop. Otherwise, if it is not equals to 0, then uses the condition of this one, then there is a return 0 and then there is a closing curly braces. Now this is the explanation of the program that is available over here. In this program we have applied a big loop in the child process. That is, we have applied the big loop that is available in the child process. This loop ensures that the child does not terminate immediately. That is, this loop ensures or makes sure that the child does not terminate immediately. From within the parent process we have made a call to the wait PID function. That is, whenever we use the parent process, we have made a call to the parent process that is done by using or made a call to the wait PID function. This function makes the parent process wait. That is, this function is used to make the parent process wait till the time the execution of the child process does not comes to an end. That is, till the time it is available, it is used with the till the time it is used with the child process. This ensures that the child process never become orphaned. Once the child process terminates, the wait PID function queries its exit code and return back to the parent. As a result of querying, the child process does not become a zombie. That is, as a result of the querying that is available, the child process does not become a zombie in this case. The first parameter of wait PID function is the PID of the child process for which the wait has to be performed. So first, this is the PID. This is the wait PID. That is the first parameter. That is only a PID. This is the first parameter of wait PID is the PID of the child process for which the wait has to be performed. The second parameter is the address of an integer variable. So second parameter is the address of the integer variable. This is the address, that is the ampersand status, which is set up with the exit status code of the child process. The third parameter is used to specify some options to control the behavior of the child process. That is used to control the behavior of the child process or child operation or wait operation. We have not used this parameter, and hence we have passed a 0. That is, we have passed the value 0 because why? Because the wait operation is not used. Next, we have made use of the WIF exited function. That is a macro to test if the child process exit normally or not. So this is a macro that is used. Macro means a predefined value that is used to check whether the child process exit or make sure that child process exit normally or not. If it is exit normally, then simply printf, that is the parent, that is the child process prints or child processes exit normally. Otherwise, child process exit abnormally. This macro takes the status value as a parameter and returns a non-zero value if the process terminated normally. Using this macro, the parent suitably prints a message to the report the status. That is, simply prints the message to support the or report the status, that is either normal or abnormal, termination of the child process or of its child process. Now, next part is one interesting fact that is available in this program or about the or beyond this program. That is the interesting fact that is available. So this is what is the interesting fact. When we use the fork function to create a child process, the child process does not contain the entire code of the parent process. That is, whenever we use the child process, it does not use the entire code of the child process. It does not use the entire code of the parent process. Then does it mean that the child process contains the data encode below the fork code that is available over? The child process contains the data and the code below the fork call. So even this is not the so this is not the case that it is used, the data and the code is used below the fork call. Even this is not so. In actuality, the code never gets duplicated. That is, the code never gets duplicated. That is, there is no duplication of the code that is available. Linux internally manages to intelligently share it. That is, Linux automatically manages it to intelligently share it. As against this, some data is shared, some is not. That is, as compared to this one, as against this one, some data is shared and some is not. Till the time both the processes do not change the value of the variable, they keep getting shared. That is, if they are available, or till the time they are not available or they do not exchange the values of the variable, they keep getting shared. However, if any of the processes, either child or parent, attempt to change the value of a variable, it is no longer shared. Instead, a new copy of the variable is made for the process that is attempting to change it. This is not only ensures that integrity but also saves the precious time. So this not only ensures that there is a data integrity but also saves the precious memory. This is the fact that is whenever we use the fork function call, or whenever we use the fork function to create the child process and the data and the code of the child process. Now this is the important part, that is the summary. That is what we have covered in this chapter. So we are winding up, or we are going to wind up this chapter, that is the summary part. This says Linux is a free operating system whose kernel was built by Linus Torvald and friends. So this says it is a free operating system that is available whose kernel was built by Linus Torvald. So this is a person, or he is a person that is available, that is a Linus Torvalds and the friends. The next point says a Linux distribution consists of the kernel with source code along with the large collection of applications, libraries, script, etc. That is, a Linux distribution consists of the kernel, that is the main part, along with the source code, along with the source code, along with the large collection of applications, libraries, script, etc. The next point says C programs under Linux can be compiled using the popular GCC compiler. So it is used, or whenever we use the C program under the Linux, it is compiled using the GCC compiler. Like in our DOS programming, we have used the Turbo C++ or Turbo C for the operating the, or for running the, for executing the programs. But whenever we use the C program under the Linux operating system, that can be compiled, or that is compiled using the popular GCC compiler. So for DOS, it is a Turbo C. For Windows, there is a different compiler, that is a VC++, and then whenever there is a C program that is able to execute under Linux, there is a different software that is available, different compiler that is available, that is known, that name is known as the GCC compiler. Next point says basic scheduling that is done in a Linux is a process. So whenever we are doing the basic scheduling, that is or that unit is known as a process in the Linux. So in simple terms, process is a program in the execution. That is, whenever we execute any program, that is a process. So processes are scheduled by a special program known as the scheduler, right? Then next function is, or next point is fork library function that can be used to create a child process. Suppose there is a one parent process, and my target is to create few child processes, that is done by using the fork function, that is also a library function. Then next point says init process is the father of all the processes. That is, init is the father, or init process is the base or the supervisor of all the processes that is available. Then next one says exe, that is executable CL, that is a command line argument library function, is used to execute another program from within a running program. This is the other function that is available, that is used to program, or that is used to execute other programs from a running program. Suppose there is one running program and we are able to execute the another programs from within the running program. Then next point says executable CL function overrides the image of the that is the code and data of the calling process that is available. That is also executable CL function. Next point says executable CL and the fork function usually go hand in hand. That is, these are going hand in hand. That is a one by one condition. The next point says PS function. This is the most important command, not a function. This is a command like PSA can be used to get a list of all the processes. So that can be used to get a list of all the processes that is available. That is the PS command. Then there is a kill command that can be used to terminate a process. So this is also a command, that is a kill command. Then next point says a zombie is a child process that has terminated, but its parents is running as a node called a function to get the exit code of the child process. So a zombie is a child process that is available that has terminated about its parents, but that has terminated, but its parents is running and has not called a function, that is a zombie process. Whereas orphan is also a child process whose parent has terminated. This the parent is not terminated, cannot get the exit code of the child process. Next point says orphan processes are adopted by the init process automatically. So whenever we use the orphan process, whenever it is used the orphan process, that is adopted by the init, that is the initialization process automatically. Last point says a parent process can avoid creation of a zombie and orphan process using the waitPID function. So this waitPID function is used to avoid the creation of a zombie and the orphan processes. Then this is the exercise, that is a true and false question. This is the answer the following question. This is the theoretical question that is available. This is what is the purpose of using the function, that is the get PID, get PPID, get PPID. So that's all for chapter number 20, that is the C under the Linux. Now next chapter is chapter number 21, that is I'm going to start in the next class, that is in the tomorrow's class. But today I'm going to continue with the practical approach, that is today's session. So let's take 5 minutes break and then move to the next session, that is a practical approach. So let's take a break for 5 minutes. So come back from the break. So let's now start with the practical approach. In the last class we have covered about practical approach on the functions, that is how to use the functions in the practical approach. Now I'm going to continue with the same approach, that is using the functions, that is how to use the functions in the C programming. In the last class we have covered about the local variable and the global variables, that is how to use the local variables and how to use the global variables using the C and the C++, right? So let's start with the new program, that is a program that shows how to use or what is the return type, that is how to return the values of the program. We have also studied one more program that is used to display the message using the user defined functions like A, B, C. Remember? Now let's move to the next topic, or the simple calculate the square of a number. That is this is the program that shows how to find out the square of a number. Find out the square of a number or calculate square of a number using predefined function or using any functions. Okay. All right. So first of all, let's take the header file, that is a hash include stdir.h or conio.h. We have, or and any file we have, right, or any file we are using and in any order. Then hash include conio.h. Then there is a void main. Then there is a curly braces, right? Then declaring the variables, for example z equals to 0. Then using the functions, first of all uses scr, that is a clear screen. Then uses one function for sqr. So sqr is a function that is used for calculating the square, that is a void sqr. Then uses the clear screen, not over here but after this one, because this is also a function that is used before the clear screen in along with the variable declaration. So that is clear clr scr function. Then uses the for loop for printing purpose. It starts with the z, yeah. Then it's end with the 15 or 5. That means it goes for the 5 iteration, 1 2 3 4 4 iteration, not 5, 4 iterations. Then there is a j++. then uses the function that is the sqr, then there in a bracket there is a j. Then uses the getch function for over here. Then close this one. Then uses the void sqr int k. That means we this is the type for declaring or define the functions. That is the sqr. Then in bracket there is a variable declaration that is int k. Right. Then uses this one and then printf. Then uses printf for this purpose. That is k into k, because we have to find the variable using the function. So this is k into k, that is used for the variable declaration, that is used for the square root of a number or square of a number. Then if I compile this code, there is one error, extra parameter in this one. So first of all we have to save it, then uses this function. So first of all save by using any name, that is a function that is square and dot cpp. Now if I compile this code, there is no error because it is running in the C program. If I compile this code, the output is 14916 or 14916. So this is a square that is coming in only one line, but we have to make it in the multiple lines, that is 14916. That means it is going for 4 times, that is for 1, for 2, for 3, for 4. If I compile this code, this is the output 14916. That means first of all there is a square of a 1, then there is a square of a 2, then there is a square of 3, then there is a square of 4. That is 14916. This is the program that shows how to calculate the square of a number using the function. But without using function, if there is a program for calculating the square of a number, that is so easy. Simply multiply the two numbers, simply multiply the two variables, that is a k into k, l into n. That is so simple. But it is the case, or it is the example that shows how to calculate the square of a number using predefined functions, using user defined function that is available, that is using the function that is available over here. So there are two header files. First of all, one is the stdi.h, then there is a conio.h. Right? There is a void main that is starting of the main function. Then int j equals to 0. That is, it starts with the variable. It starts with this one, that is j equals to 0. Then there is a function declaration, that is a function calling that is used, that is the void sqr function. So sqr is the name of the function and void is the return type. This is void sqr function. Then there is a clear screen for clearing the screen. Then uses the for loop, that is for j equals to 1, j is less than 5, j plus plus. So it starts with the 1 and it ends with the 5. That means it will execute for the 4 times. Why 4 times? Because 1, 2, 3, 4, not 5. 5 because it is less than 5. So it will execute, or it will run for the 4 times, that is 1, 2, 3, 4. Then there is a function that is available, that is a sqrj. That means it is using the j as a variable that is used with the for loop, and sqr the name of the function. So this means this is the declaration of the function. That is, what is the function, what is the return type of the function. This is the function calling, that is, it is using the actual argument. That actual argument is passed to the formal argument whenever we use the function definition. So this is the function calling and this is the function definition. Right. So whenever the cursor moves or whenever the cursor is over here, it directly jump to this one. It directly jump to the next point, that is a void sqr int k, that is used for the square. Then int k, that is the k variable is used. Then there is a printf, that is %d k into k. That means the square of a number, that is k into k. In this uses the return type, that is void. The name of the function is sqr and the argument that is used, that is k. In function calling, the argument that is used is the j, but in function definition, the argument that is used is the variable k. So these are the actual argument and the formal argument. This is known as j is known as the formal actual argument, and k is known as the formal argument, right? Then there is a printf statement for printing purpose, that is k into k. That means multiplying the variables for finding out the square of a number, for finding out the square of a variable, that is, or function, that is we are given in the for loop. So it starts with the 1. So first of all it is 1, then there is a square root 1, this is 1, the 1 is coming over here, that means 1 into 1 is 1, that means prints 1 into 1, that is a 1. Then there is a j plus plus, that means there is a 2. Check the condition, 2 is less than 5, condition is true, simply passes the value of 2 over here, getting the value of 2 over here, getting the value of 2 into 2, that is 4. Then uses 3, that is j plus plus, that is 3 is less than 5, condition is true, that is sqr j, that means condition is true, that is the sqr, that is 3 into 3, that is a 9. Then again j plus plus, that is 4, 4 is less than 5, condition is true. Then again uses the square function, that is the sqr j, that is a 4. Now uses the 4 into 4, that is 16. Now j plus plus, that is becomes 5. Check the condition, 5 is less than 5, condition is not true because it is equals to 5, not less than 5. Then the loop will terminate and the 4 values will print, that is 1, 4, 9, 16. So this is the way how it is used for calculating the square of a number using the function. But if simply we have to find out the square of a number without using any function, then it is so simple. But with using function, this is the trick that is used for squaring a number, right? So if I give the comment over here, this is the variable declaration, you know, this is the function declaration. That is, the function is declared over here. Then this is okay, this is okay. Then this is the function calling, that is, the function is called, this is the function definition. Then this is used for the printing. So these are the 4 points that is used. Now if I compile this code again, 14960. So I think this program is clear to you. If there is any doubt, then please mail the doubts to me. So these are the variable declaration, finding out the square of a number, there is a function calling, there is a function definition, there is a function declaration, right? So this is the way how it is used. Now let's move to the next program. This is the square that we are done, that is how to find the square of a number. Now let's see a program that is used to send the values to the user defined functions and receive and display the return value. That is how to use the return value. That is, first of all, hash include stdio dot, then hash include conio dot hash, then there is a void main for main function. So this is the program, write a program to send values to user defined function. This is a program that shows how to pass the values or send the values to the user defined function. And receive and display the return value. So two header files are used, that is the str.h and the conio.h. Then there is a void main for the main function. Then first of all uses the variables, declare the function, that is the sum. Simply declare the data type of the values that is used, that is int. Now this is the variable that is declared. Now again uses this one, that is the int a b c s. Now clear the screen, then uses the printf. That is enter three numbers. Then uses the scanf for storing into the memory, that is %d, %d, percentage. Then storing in the memory, that is %a, %b, %c. So these are the three variables. Then uses the next variable, for example s equals to sum. That is sum is used, that is a sum function is called, that is the a, b, so the output of this function, that is a sum abc, is stored in the variable, that is a c. Printf for printing purpose. That is sum equals to %d, that is %s. In this we have to change the variable as s because c is used in this one. Now there is a return 0 or there is a get ch. Now this is the variable declaration or function declaration, that is sum is used, int x, int y, int z. Then there is a return for returning the values, that is a return. Then simply uses x plus y plus z, then uses this one. If I compile this code, there are 4 errors. What are the 4 errors? That is a statement missing in 13th line. Yeah, where is 13th line? This one. Now if I compile this code, there are 3 errors. Function return should have a prototype, undefined symbol, z and y. This z and y are the undefined symbol. Why? Because this is in a caps lock. Now if I again compile this code, there is only one error that is expected. That is, this is expected over here. If I again compile this code, till now there is one error, that is the function return should have a prototype, that is it must have a prototype over here. What kind of value it could return? Either it could return a integer value, either it could return a discrete value. That is, if I write this one, now if I compile this code, there are 3 errors. there is no usage of this one. There is only one error, that is in 20th or 19th line. That is the function return should have a prototype. That is x plus y plus z. So in this, the sum function is used for getting the input. So there is an error that the function return should have a prototype. Now first of all I have to save this file using C extension. For example, the name of this one is the user defined function. Yes, if I save this file, now again if I compile this file, there is no error, or there is only, that is function return should have a type, that is it should return anything, that is a function return should have a type, or should return any values that is used, that is a plus is used, that is int x, int y, int z. There is a function that name is sum abc. So these are the variables that is declared in bracket only, that is return x plus y plus z, that is return, and the output is stored in the s, but I don't know where is the lacking. Why this happens? Function returns some values, should return a value, that is a plus b plus c. If I use this one, that is a void, and if I compile this code, there is only one error, that is expression syntax. This is the case that shows that function should return any value, int x, int y, int z. There is a sum function that is used. There are three variables, there are three actual formal arguments, there is the x, y, and z. Right, so this is the case, or this is the user-defined function that shows how to use the sum, or how to calculate the sum, or how to use the, or pass the value of the user-defined function and return the return type, or display the return type. Now this is a function that is used, that is the winding up of the function, that is int x. I don't know where is the error over here. There is a return 0, there is a int sum that is of int int int. Okay, so there is a return 0 over here because we have used int int int. All right. Return 0. Now if I compile this code, there are two errors. Undefined symbol, that is a return y. Now if I execute this code, there are one error, that is undefined symbol return, that is also used over here. Now enter the three numbers, for example 4 5 6. The output is sum equals to 15. So this is the way how it will be used. So if I does not use this one, and if I compile this code 2 2 2, the output is 6. So this is not mandatory to write, right? So now understand this example. First of all, my target is to send the values to the user defined function. So this is the program, this is the example that shows how to pass or how to send the values to the user defined functions and how to receive and display them, and that is how to receive and then display to the with the help of the return value. With the help of this one, that is how to display this value, right? So there are two header files that is used. One is the hash include stdi.h, that is the standard input output.h. One is the common input output.h. Then there is a void main. Then there are this is the function declaration, that is the function what should it contain, that is the int sum. So sum is the function and int is the data type that is used, and there are three types of arguments, or there are three arguments that is covered, but three are of type int, that is we cannot enter the float value, that is a decimal value in this function. Then these are the variable declaration that is used, that is a b c s. Then there is a clear screen. Then uses the printf, that is enter the three number, that is it is user defined, that means it is used for the user, that is a 3 times 5 times whatever the need. Then printf, that is %t, that simply prints the memory or prints in the memory, that is a b and c. Then uses the sum function, uses the function that is a sum, that is the output of the sum function is stored in the s. As soon as the cursor moves to the sum function, it directly moves to this one. Why moves to this one? Because these ABC are the formal argument, and this XYZ and the these ABC are the actual arguments, and this XYZ are the formal arguments. So what is the difference between the actual argument and the formal arguments? Whenever we call the function, whenever we use the function, whenever we call the function, so there is a parameter that is passed, that is known as the actual parameter. Like in this case, ABC are the actual parameters, and whatever is received with the function definition, like in this example XYZ, these are known as actual arguments. So when it is passed, it is called, that is known as predefined function, and after this is known as user defined functions, right? This is sum equals to s %s, right? Then this is the function definition. Three variables are used, x, y, z, and there is a return type adding of all the values, that is x plus y plus z, and the output of this is stored from over here only, that is printf sum, that is the s will be printed, right? This is the way, this is the step-by-step execution how it will work. This is the program that shows how the user defined function will be used in the C programming, that is how it will be access the code. Now the next concept is the call by value and the call by reference. That is also the most important concept that I will covering in the next class, that is the tomorrow's class. Now let's see in another program, that is how to pass the arguments to user defined functions by value and the reference. Then functions as the argument we are using. Now let's move to the next program. So first of all, the program name is write a program to pass a user-defined function as an argument. Now there is a hash include, that is a header file that is used, that is a hash include stdio.h, then hash include conio.h. So these are the two header file that is used. Now there is a variable void main. Now there is a variable declaration, for example y equals to 2 and x is blank. Then there is a function calling, that is x equals to, what is the name of the function? That is a square double or the double square. This is double, that is a double, then in the bracket there is a square, that is a square, then in this is the parameter for this one. Now uses the printf for this purpose, that is it will use over here like this. Now it uses the getch function. Now there is the closing of this void main. Now we have to use the functions, but this is printf, that is how to use the printf. Now we have to use the functions, or there is a definition of the function, that is double, then there is in a bracket there is a m, again it is used, then this is the definition of the double, that is return, bracket open, there is m into 2, that is multiplied by 2. So this is returned, and after this we have to put the curly braces. Then there is a square, one is used for this one, that is a square. This is the square function that is used. One is the double function, this is the square function. And then there is a k. Then it is also uses the return k into k. Then simply returns the value. Now if I compile this code, there are two errors. Now let's see, function square should have a prototype. Where is the function 7? So what is the error over here? One of the error is function square should have a prototype, that is the square has a prototype over here, that is the k, and the y is known as the actual argument and k is used as the formal argument. The next error is declaration syntax error. There is a problem in the declaration, that is a syntax error. There is the return value, that is returned square. Now if I save this file, First of all, give the name pass.html, that is passing. This is, for example, pass. Now, if I execute this code, there are two errors remain, that is expression syntax that is never used. Seventh line is expression syntax. That is x equals to double, that is square, then there is a y, then there is a square one, that is a square close, that is a square, then there is a variable that is y is given over there, then uses the x for storing the values of the double square, that is a double square y, then this one, then uses printf for x equals to percentage d, then there is a value of the x that is printed, right? Then there is a variable declaration, that's double sum m into 2 k into k, so the output is 80. Expression syntax, and y is assigned a value that is never used. This is not executing. So let's stop over here only. In the next class, I will be starting your next chapter, that is chapter number 21, that is a more Linux programming, that is more focus on the Linux programming, how the Linux programming is done. So thanks a lot everyone, and please listen to me carefully. Again the same talk. If there is any doubt, then please text the doubt and I will answer you. Text the doubt means for date or today, that is the day today, that is tomorrow's and the day to date class. Please focus on this one, that is focus on the class, and if there is any doubt, then please mail the doubts and I will answer you. So that's all for today's session. Thank you so much, and I will be present in the class from Monday only. So please pay attention to the next two classes, that is only for the tomorrow's and the day after tomorrow class. And if there is any doubt, then mail the doubt so that you cannot forget the doubt and I will answer you individually. So that's all. Thank you so much. Bye bye everyone.